PubNub connects over 1 billion devices, humans and AIs that allow businesses to power all sorts of online interactions like chat communication, multiplayer gaming, geolocation, and a whole lot more. In addition, you can provide intelligence around those connections. As a player is making a move or a user sending a chat message to another user, you can aggregate that data and then make decisions on that data in real time to trigger additional actions. That's through PubNub Illuminate. Now, we also want to make innovations every day, and security is an extremely important aspect of that. And we've made a significant leap and improvement with our security layer. Just recently, last week, we deployed a new Rust app in production that manages all of PubNub's security layer. And this is really critical from a perspective of performance, but also overall security. Rust provides an additional layer of safety that other languages don't as much. The compiler protects us against two major critical aspects that often get overlooked when you deploy them into production. With Rust, the compiler takes care of concurrency challenges that you might run into in other languages. Also, it takes care of memory challenges. And these two things combined represent over 70% of the bugs that make their way into production. This is why PubNub is leveraging Rust to make our infrastructure even better. And this is critical for us because we deploy our code globally across all of Amazon's availability zones. And we want to make sure that all of our data centers are able and capable of scaling quickly to the demand of your users as they connect to the closest region, allowing them to get excellent and fantastic latency. Overall, their experience is important to us. We need safety, security, and the performance needs to be really good, so that way they can have a really good user experience. We've built this global infrastructure based on Kubernetes, right? We deployed all of our containers in a Kubernetes infrastructure that allows us to, on demand, scale the number of servers that we need independently in all of Amazon's availability zones. We treat every single Amazon AZ as a separate region that users can connect into. And this allows those separate regions to scale up and down as needed based on the demand and the load. And this is how we've built our infrastructure on top of PubNub, and we are adding in Rust every single day to make that better. And we've done it again, and I'm excited to share with you some of the numbers in latencies and CPU utilization. Last week, we deployed our next-gen Rust authorization layer into production that takes care of all of the API calls going through PubNub's system. That we have a specific auth layer that runs in all of our data centers globally. And we did it. You can see here on the screen, the moment that we clicked the go button, the new Rust pods deployed in one of the AZs and started taking over the traffic safely through an AB blue-green deployment style. We saw the number of API calls that it was servicing increase, and that's the moment that it went live. But the question is, how did it perform? Did it perform well? Did we see an overall improvement in latency, CPU utilization, memory, and other things like that? Yes, of course we did. We definitely did. We saw with Rust, we see a significant performance improvement, which I'm very satisfied for. Just take a look. Let's do the before and after. All right, so we are currently running the previous generation authorization layer, which is our security layer at PubNub for all of the API calls coming into the system. We see that we see about 20 pods here in one of the AZs running specifically at around, it looks like 50% utilization, right? So it's using a half of a core with 20 pods. So that's about 10 full CPUs, right? Essentially, for just that AZ alone, and just for, it looks like around 250,000 API calls. Or is it per minute, yeah. So then we can see we see the new Rust-based auth pods spin up here, and they're using less than half the number of compute core, right? So it's looks like around 20% CPU utilization comparing to 50% CPU utilization. Additionally, there's only a need for 3 auth pods in this AZ, which is the absolute bare minimum that you would need. And so you pick this Rust is the winner. clearly in terms of the performance overall. So you see before and after, right? We have our previous generation, 20 auth pods, 50%, down to 3 auth pods with 20% utilization. Wow, that is a significant improvement. Not only does this help protect us and our customers from an API perspective, because now we can scale a lot more easily as load occurs and demand increases on the API calls. This allows us to also provide a layer of security advantage. With Rust's built-in protections for concurrency protection and memory safety, this gives us that control of general safety that we didn't have as much when we covered in our previous generation authorization layer. But does it scale? Does Rust scale to the load and the demand that's needed by APIs that have unpredictable workloads that are completely driven by user behavior? Either a large event occurs or a large amount of users come online. They need that API immediately. Rust help us scale. Yes, it can. Check this out. We are looking here at a screen where we were running just fine in one of the AZs where we deployed our new Rust service, the Rust service layer, right? So we're running Rust here, and it's running around 250,000 API calls per minute here. And then suddenly we see an increase, a load increase, and it jumps up to just over 5.5 million. That's a lot. That's a huge amount. That's the number of API calls per minute that we need to be able to service. And it just grew and grew and grew. And guess what? Rust handled it perfectly well. It's actually kind of funny. You would say, okay, so we had 3 Rust pods running. What happened to those 3 Rust pods? Let's see what that looks like. Okay, so we see here, we're at the time the scaling started to occur. We saw a downscale event, but guess what? We needed to upscale. So it increased, it added a pod right around here. So we see 1, 2, 3 lines here that were servicing the traffic just fine. And this looks like the CPU utilization was using, it had to increase obviously, right? We needed a few more cores. So it did, it grew up to 1.5 cores used for these pods. And then it's like, okay, maybe we should add a 4th pod. And then that allowed it to scale. So now we're running 4 pods, 5.5 million API calls serviced per minute. Wow, that's a significant improvement. Just imagine the old auth layer, how much more scaling it would have had to do in order to catch up. That allowed us to scale to the needs of the customer's APIs. Did a really good job in this case. But you might say, oh, hold on a second. What was the latency? So we saw the traffic increase in this AZ, right? And this is just one of the AZs, right? So this is like 3% of all of PubNub's production traffic, right? So you take a look, and we saw this one AZ went from 250,000 API calls per minute to just around 5.5 million API calls per minute. Let's take a look at the latency chart. Oh, look at that. Now you might say 400, 200. That seems like a big number. What is that? Hold on a second. These are microseconds. Not milliseconds, these are microseconds. These means fractions of a millisecond. That's really fast. So we saw as we were operating normally just fine, we saw, well, it looks like, hundreds of microseconds, right? So it's like basically 1/5 of a millisecond. Wow. That's really fast. And then the scale occurred. The scale went up. We needed to launch an extra pod. We saw this the latency spike. Oh no, the latency spiked. What did it spike to? It looks like around 0.5 millisecond. So that's a nice increase there, but not something that you would notice as a human. We can't even really perceive what 1 millisecond looks like. This is 0.5 millisecond. Then as that pod warmed up, it was able to restore back down to what looks like 106 microseconds. That is a significant improvement over the previous API, which was definitely way over, it was probably in like the tens of milliseconds and required a lot more compute, a lot more pods, a lot more memory, and it had more latency. Rust gave us this power that you're looking here on the screen. This is the power of Rust. This is what our team was able to leverage. It's really powerful. And this is the 7th or so service we deployed into production using Rust as that core language technology. And it has given us a significant advantage that we can offer to our customers.